If the velocity of a single constituent particle is being referred to as the quantity of motion, what about a scenario where we have a mass of, say, 5 kgs? Because basically, in that scenario, we do not have a single constituent particle. We've got a lot of particles involved. If for a constituent particle, I'm saying the quantity of motion is v, the velocity. Remember, constituent particle, and what I'm referring to as the constituent particle is the smallest particle of matter possible. So if this is the quantity of motion for a constituent particle, what about for a huge rigid body? Say this is the body and it has it's made up of a lot of particles. The number one thing to remember in this case, and it would be very, very helpful if you watch my video on the difference between mass and weight. The number one thing to remember is, if this is a body and these are the constituent particles that make it up, that is the smallest particles of matter possible. Now look at this body. It has 1, 2, 3, 4, 5, 6, 7, 8, 9. What does that mean? It has a mass of 9. That is, m is equal to 9. You may say, let's just call it 9 units. I don't know how the term you're going to give to the units. Let's just call the mass 9 units. So if this is a certain huge body or a huge mass, how would you get the mass? You'd simply, if we could, it's unfortunate we can't go zoom in on the particle, on the body, and count one by one the constituent particles that make it up. But if that were possible, what we'd simply do is look at the constituent particles and begin counting them one by one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Consequently, because there are 9 constituent particles that make up the mass. And what is mass? Mass is a measure of the quantity of matter. The quantity of matter in this case is 9. So the mass is 9. I then go back to the question. What would then be the quantity of motion? Say this is a rigid body now, and all those particles were moving with a velocity of v. I'll repeat, all those particles making up this rigid body. Remember, this is just translational motion. This is translational motion. If all those particles were moving with a velocity v, what then would be the quantity of motion? The quantity, now pay attention to the terminology. Newton was very clever on this one. Pay attention to the terminology. Quantity of motion. We have already determined that for a constituent particle, the quantity of motion is just the velocity. But for a rigid body now, the quantity of motion becomes this. Because this, for a single constituent particle, v is a quantity of motion, is the quantity of motion. If we take 2 of these, the total quantity of motion in this case becomes v plus v. That is 2v. And if we take this third particle, now this only applies when we're going in the same, like when all the particles are headed towards the same direction. If we take this particle, we've got a total quantity of motion of v plus v plus v. So if we go on and on and on and on, we'll find that we'll get a total quantity of motion of what? In this case, where we've got the rigid body, we'll get that we have a total quantity of motion of 9v. That is v plus 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 v. So when you see the 9 appearing in Newton's second law, the 9 appears because we have 1, 2, 3, 4, 5, 6, 7, 8, 9 particles. That is 9 constituent particles. So this 9 can now be replaced by m. Since, remember, we've got v plus v plus v plus v, and it all adds up to 9v. But what else have we got that's represented by 9? It's the quantity of the matter, the quantity of the constituent particles that make up the body. So we can replace that 9 by m. Consequently, mv becomes the total quantity of motion of this rigid body. So if you now look at it, what you call momentum is actually just the total quantity of motion of a body. That's it. That's all, guys. It's very, very helpful if you bear this idea in mind, and it will help you. This is what helped me understand energy better. If you look at my video on work done, this is what helped me understand energy better. Picturing things in terms of quantity of such and such, quantity of such and such. But it's very, very helpful if you first have a good framework of what space, time, and motion is. It does not work if your ideas of space, time, and motion are shaky, are broken. So this is all there is, guys. This is where the term quantity of motion came from. It came from the fact that if this is a huge body, if this is a huge mass, you simply have to count the quantities of motion already available for each particle. So 1, 2, 3, 4, 5. So you, in this case, like we already saw, we've got 9 of these quantities of motion. So we've got a total quantity of motion of 9V. But since 9 is also the value of the quantity of the matter, we can simply replace it by m. So the quantity of motion becomes mv. Hence, the momentum, which is equal to mv, is simply the total quantity of motion. I hope that one sinked in. I hope that one sinked in, guys. So that is it, guys. I really hope you benefited from this video. The quantity of motion. Now, I want you to notice something. I referred to this instead of the quantity of motion, instead of simply calling it the quantity of motion, I termed it the total quantity of motion because I had used the term quantity of motion on a single constituent particle. So in the case where you have a huge mass, you can simply use the term total quantity of motion. And in the case where you have a constituent particle, you can simply use the term quantity of motion without the total. So that is it, guys. That is it. That is the intuition behind momentum. If you picture it in terms of total quantity of motion or quantity of motion, you'll be better able to grasp a lot of concepts involving motion in physics. So I hope you benefited, guys. And hopefully in the following video, I'll be able to explain how picturing it this way will help you understand this better. Because remember, if you read Newton's second law in his Principia, the way it's termed or the way he put it doesn't naturally bring this out. It naturally brings this out. You can let me know in the comments in case I forget. I intend to explain this using this idea of the quantity of motion, because if you really understand how to picture momentum in terms of quantity of motion, then this becomes very intuitive. Instead of this, but again, this also makes sense. If you look at my video on Newton's second law, this also makes sense if you approach it with the right framework. So I'll also make a video on explaining how we can view or why dp over dt makes sense when you're looking at it from this perspective. I'm not debunking this. This makes sense. But this, if you think about momentum as the quantity of motion, this also comes with a lot of good. And this naturally, unlike this naturally transfers or pours over to Newton's third law. But I guess we'll look at that in another video. So thank you, ladies and gentlemen. I hope you enjoyed and benefited a lot from the video. And I hope it will help you approach physics in a different way now, as compared to the way you were approaching it when you didn't know what idea or what momentum really is. Why Newton termed it quantity of motion instead of just like a random name where he just plugs in a name like momentum. So that's it, guys. If you have any questions, please let me know in the comment section. I'll be happy to reply when I find the time. Please leave a like, subscribe, and comment if you enjoy the video. Stay motivated.